In this video, we'll discuss the area of parallelograms. Now, we can use the moving and additivity principles to help us recreate that parallelogram and understand how the area works when we're on grid paper. For example, here is a parallelogram. If I use the additivity principle, I could draw two vertical lines from the bottom side to the top side and see that I construct two triangles and a square. Then I can find the area of each of those shapes individually, add them together to get the entire parallelogram's area. So in this case, this area, the first one, that's a triangle. That's 1/2 of the base times height. So I'm going to use this as my base, and here's my height, 2 by 3. So that would be 3 units. Then I go to the area of the second one. That's a 3 by 3, which would be 9 square units. And then the third one, again, that's a 2 by 3, another 3 square units. So if I add all three of those measures together, I would get that the area of this parallelogram is 15 square units. Now if I use the moving principle, I could look and say, I'm going to take this right-hand side, draw a vertical line, I'm going to cut that triangle off, and I'm going to move it to the other side. Now instead of a parallelogram, I've constructed it into a rectangle. I didn't stretch it, so I've maintained the moving principle. It's the same area. And now if I look at that rectangle, I would do the base times the height, which is 3 times 5, and get that this would be 15 square units. And that leads to the fact that the area of a parallelogram is base times height. The key is that we can use any side to be the base, and we're just going to use that chosen length, and the height will be the perpendicular distance from the chosen base to the opposite side of the base. So let's look at this parallelogram here, ABCD. One thing I could do is I could choose side AD, because that is an easy side to measure in this image. That's one of the key ways I often think about if I have a grid like this. Use the side that's easy to measure as the base. And I can measure that and see that is 4 centimeters. Now I need a perpendicular distance from AD over to side CB, so I'm going to call that segment AE. And if I construct that, that will be 3 centimeters. Now to find the area of the parallelogram, I'm going to do the base times the height, which will give me 12 square centimeters. Now we could have also used side CD. We could use Pythagorean theorem to get an exact measurement of CD using the grid to help us with that, or we could use something like GeoGebra to measure that for us and get an approximate value of 3 and 6100 centimeters. Now I need to create a perpendicular distance from CD over to side AB. So I'm going to create segment CE perpendicular. And when I do that, again, I'm going to use GeoGebra to help me measure that and construct it, and that becomes 3 and 3200 centimeters. Now I'm going to multiply those two values together, and because it's 3 significant figures for each of those values, I would say that it would become, again, 12 square centimeters. So it didn't matter which side I used, as long as I could construct those segment measures, I would still end up with the area of this parallelogram being 12 square centimeters.